Quality control. The biochemical test results of a laboratory plays an important role in the diagnosis and treatment of the disease. An error where the test value may result in wrong diagnosis, unnecessary treatment, or a prolonged hospitalization. The unnecessary hospitalization puts a extra financial burden on the patient. Hence, the quality of such a test must be controlled. High quality of biochemical test results can be achieved through adopting standard quality control programs in the laboratory. Nowadays, it is necessary to release the new test after complete review. It is necessary for the clinical biochemistry to check day-to-day error and to make and to take necessary steps to minimize those errors. The International Federation of Clinical Chemistry expert panel defines the quality control as a study of errors which are responsible for laboratory and procedures used to recognize and minimize them. All steps should be taken by the laboratory to ensure reliability and accuracy of the laboratory results and reproducibility and comparability to producers with other laboratories. The high quality and accuracy of the test results are achieved when the following points are taken into consideration: cleanliness and glassware, daily maintenance instrument, use of specific and sensitive method for assay, training of laboratory employees, international definition, quality assurance, all those planned and systemic action necessary to provide adequate confidence that a service will satisfy gives a requirement for quality. Trueness, the closeness of agreement between the average value obtained from a large series of test results and an accepted reference value. Precision, the closeness of agreement between the independent test results obtained under the prescribed condition. It may or may not be accurate. Bias, difference between the exception of the test result and acceptance reference value. Accuracy, the measure of closeness of an estimated value to a true value. Error, the results of measurement minus a true value of a measure. Repeatability condition, the condition where independent test results are obtained with the same method on identical test items in the same laboratory by the same operator using the same equipment within short interval of time. Uncertainty of measurement, the parameter associated with the results of measurement that characterize the dispersion of values that could reasonably be attributed to the measured. Quality control measure, the quality control material used for the purpose of internal quality control and subjected to the same or part of same measure procedure as that used for test material. The pooled and lyophilized normal serum forms the quality control material. These materials can be procured from the suppliers with analyzed values. The quality control materials are mainly available in the powder form. Once we dissolve this material to a desired volume, it can be distributed into several vials and stored in the refrigerator. Every day, the vial of low and high quality control materials can be used. Preparation of a quality control material. The serum samples are collected. Pool the serum sample together 1 to 2 liters. Serial the serum sample for various infectious diseases. Filter the pooled serum through glass wool taken in the funnel and mix it thoroughly. Adjust the pH to 7.5 using concentrated sulfuric acid. The distribute 10 ml portions of this into several plates plastic vial and store in the deep freezer, and this is stable for 3 months. Each day take one vial and bring it to the room temperature. Once it is liquefies, analyze the value. Enter the value of the quality control chart. If the value on a specific day falls within plus or minus 2 standard deviations, that indicates that all reagents and standards are good. The case in case the value is above or below plus or minus 2 SD standard deviation, this indicates the reagents or standard has a deteriorated reagent. They repeat the assay with fresh reagent and standard. Sometimes the control serum itself deteriorate because the improper storage, so replaced with the fresh control. Standard deviation, if the specimen is analyzed several times, the result would be around the mean value. The mean differences of each value from the mean is a standard deviation. Coefficients of variation, the expressed deviation of results. Control chart, Lewis-Jenny chart. Quality control, a set of measures useful in detecting error Error can be minimized by exercising control on three factors: a pre-analytical variation, patient identification, preparation, specimen acquisition and transport, turnaround time and specimen processing, work list preparation and maintenance of a work record. Analytical variable, selection of appropriate method, standardization and calibration, documentation and verification of a procedure, monitoring critical equipments, materials and report. Control of analysis quality, monitoring quality through the use of control serum, chart and records. Analysis of internal QC program, set the procedure undertaken by the laboratory staff for continuous monitoring of operations and results of measure in order to decide whether results are labeled enough to be released, can be designed without much difficulty based upon analysis of patient sera, the clinical correlation of the test with the disease the patient is suspected to be suffer from within assay variations. Analyze the sample twice during an assay and note the result. Ideally, if no random or systemic error existed, but both the results should be identical, and the large variations in results indicates the effect of one or more errors. The correlation with other laboratory results, the results of a particular test must be correlated with the results of other related tests. Intra-laboratory duplicate of days. The samples can be analyzed in duplicate for 2 days and 4 values studies for reproducibility. Variation in 4 values indicates one or more random or systemic errors. Data check with the previous test. The results of a particular test may be compared with the results of previous test on the patient. If the disease progressing, the value must be increased. If the patient is in recovery phase, the results may show a decrease in analytic concentration. If not, this indicates error. Patient daily and monthly average data. The law of average states that average daily or monthly value of a particular parameter like glucose must lie within the very small range. This can be calculated by formula. Using pooled sera, the samples containing normal and abnormal level of analyte may be pooled daily until sufficient quantity is collected. The pooled sera are kept in the freezer, filtered, aliquot transferred to same vial and then frozen. The serum is then analyzed and appropriate values assigned as shown in the analyze 2 vials in duplicate for 10 days. Calculate the mean and standard deviations for 40 values. Use of commercial assay sera. An assay control sera may be included in the assay and results compared with the expected value provided with the control external QC program. The system of objectively retrospectively comparing results from the different laboratories by means of survey organized by the external agencies. Several external quality control programs are available. The participating laboratory is sent vials of control without reference value. The laboratory may analyze these samples as many times as they wish and send their best results to the reference laboratory. The reference laboratory then assign the variance in the index score, which is calculated for glucose as shown. The internal QC program is the most useful determining the reproducibility of result. The external QC program are useful to determine the closeness of result in to the true value. Random errors. There are errors which arise due to the inadequate control of pre-analysis variations, such as patient identification, test patient correlation, labeling of sample collection, handling, transport, and electrical supply and equipment. System errors. These are the error resulting from the inadequate control on analysis variables. System errors most often can be traced to faulty calibrations, which includes use of impure calibration materials, erroneous labeling of calibrators, use of wrong, unstable or deteriorated calibrator, unstable reagent blanks, and inadequate use of sample blank are also factors which contributes to systemic errors.